Hello and welcome to another video introducing you to DesignScript. So in this video I'm going to talk about collections. In my previous video, range expressions, I discussed on a means of generating a series of numbers between a start number and an end number. And this allowed you to create multiple objects using these kind of groups of numbers as input to the constructors of, say, a line. Collections are the kind of general term for this phenomenon. In other words, a group of numbers all in a single object. So collections, unlike range expressions, don't necessarily have to be sequentially ordered or going from a start point to an end point. They can be homogeneous, in other words, all the same element, or have multiple depth. So I'm going to kind of go into collections in more depth right now. So we can begin by importing product geometry. And then generating a series of numbers as we did in the last video. And then printing these. And then finally making this kind of points from them. Right. Oops. Let me put in a few more numbers in there. All right. So if we run this, it's going to generate a series of points. Now, as it's written here, point takes a whole set of numbers, this one right here, ranging from 0 to 9.75, and it generates a series of lines, or points rather, from there. Instead, if we only wanted to access one element of the collection, we can do that with the kind of square bracket operator. So what this is doing is it's sort of reaching into this collection, this bag of numbers, and only grabbing a particular element. Now you might think this would be the sixth element, in other words, going 1, 2, 3, 4, 5, 6. But actually, in DesignScript, like most programming languages, you access the first element with 0, and that's for mainly historical reasons. So num0 is going to be 0, and then num1 is going to be 0.75, and continuing up from there. So if we rerun this, we can see that point has only generated 1 point based on one number out of the collection. So furthermore, what we can actually do is, instead of just passively only using one element in the collection, we can actually change numbers in the collection. For instance, we can say, well, maybe num4, which would be 0, 1, 2, 3, 4, instead of 3, maybe we want this to be equal to 10. So here we're kind of reassigning the value of num4. That way, when we run this, of course, it's not quite very distinct. So let me just change it to 20. So we can see here, we have the first element, second, third, fourth, and remember 4 is really the fifth element. And that one gets moved all the way over here, and the rest of the collection continues as planned. So we can see this number updates here. We go 0, 6, 5. Instead of 3, we now have 20. An even more advanced means of generating kind of numbers, or sort of collections rather. Say we have P2 is equal to point dot y coordinates. Make a num2 1. And num2 is going to be generated from num1, but let's say, hypothetically, we only wanted a select few of these numbers. Say we wanted num, but we wanted 0 to maybe the 9th element, increasing by 2. So in other words, we're going to go 0, 2, 4, 6, 8, and might as well make this a clean 10. Which you'll get essentially every other number in num and put it into num2, and we'll generate P2 based on that. So again, here we are. Here's this second collection. And as you can see, it's essentially grabbed every other number of the collection. And we can sort of increase this by 3, say, to sort of similarly break it out. Here we have 0, and then 3, 6, 9. So creating a subcollection using a range expression inside the indices value. One last thing to note is a utility function called count, which does, as I've done here, sort of counting the number of elements in a collection. So we can print this. We're going to print the number of nums. So here I'm using count, and count returns a number, which I'll print, and same here. So we can see that num actually contains 14 elements, and num2 contains 4. 1, 2, 3, 4. Okay, that's all for collections. Thanks for watching.